All right, so today's date is the 14th. We're going to work on our warm up. Okay, after which I'm going to go over the workbook problems that we did for homework. It's workbook page 26. Then I'll have some independent practice problems that I need you to work on. Okay, which will be for a grade. Okay, so we need to make sure that we do our best. We're going to check those and submit the problems on Canvas. Um, Then, if I have time, I will do an introduction to literal equations. If I don't have time to do introduction to literal equations, then I'll do that tomorrow. Tonight, you're working on set 4B. Tonight, you're going to work on set 4B. And if you didn't finish the classwork, you need to make sure that you finish your classwork problems, and it will be the independent practice problems. Okay? All right, I'm going to pause. I need you to work on your warm up. All right, let's look at the warm up. This fraction, this negative fraction, is it rational or irrational?
Rational.
It's rational, okay? This is rational. It's a number that can be written as a fraction. All right, here we're going to write this again in standard form. We write the number 9. Remember, if we multiply it times 10 to the 4th power, that's moving the decimal space over 4 times. Since it's a positive exponent, the number is going to increase, so we're going to move it to the right. The decimal is here if you don't see it. You're going to move it 4 times to the right. 1, 2, 3, 4. You're going to put zeros as placeholders. So your answer is going to be 1, 2, 3, 4. It's going to be 90,000. We are comparing. Okay, place values here. This is a small number because it's a negative exponent. This is also a small number because it's a negative exponent. So these numbers, in both of these numbers, I would move my decimal over here 3 times to the left, and here I would also move it 3. Well, is that 3? Yeah, 3 times. So I'm still looking at 3 zeros before it. Then these two numbers, I'm gonna line them up so you can see it. 1, see 1, 2, 3. This is 2 zeros. And this I do the same. 1, 2, 3. 2 zeros. And what I'm doing is lining up by the decimal so I can compare. These are the same. These are the same. These are the same. This is the same. So we get to where they're different. We got 4 and we got 1. Which one is greater? It's going to be the one that has the 4. So here, this number is going to be greater. Okay. Any questions about how I convert it? And then how I line up by the decimal and compare? Which two whole numbers or the square root of 86 is between which two integers? Yes. 9 and 2. Okay. Not 9 and 10. You said 9 and 10. I thought you said 2. 9 times 9 is what? 81. So the perfect square root is 81. Then we got 10 times 10 is what? 100. So the other perfect square root is 100. And 86, the square root of 86 is between these two perfect square roots. So my answer is 9 and 10. Please make sure that you show your work, okay? Now we're going to solve. We're going to solve this equation. How do we solve this equation? Yes.
You find out what something by itself equals 225.
All right, so plug and chug is what he's doing. What number can be multiplied times itself to give you 225? What did you get? 15. What's the other way that I could do that besides plug and chug? Yes. How would I get n by itself? I'm solving this systematically as an equation.
You find the square root.
Find the square root on each side. The opposite of squaring a number or using inverse operations is to find the square root on both sides. What's the square root of n squared? N. And what's the square root of 225? 15. Okay. All right, let's simplify. So let's reduce the numbers. Let's reduce the fraction first. So when we reduce 10 over 15, what will go into both 10 and 15 evenly? The highest? Yeah, 5. Okay, so I'm going to reduce by dividing both the top and the bottom by 5. Okay, I can do that over to the side when I reduce. And that gives me what as a fraction? 2 over 3. 2 over 3. So I have 2. I have 2 over 3. So now I can do this out to the side. We got 8 to the 8th power. X to the 8th power. Okay. Here, the shortcut is to just subtract the exponents. That's 8 minus 8. What's 8 minus 8? 0. That's going to be 0. Any number raised to the 0 power, anybody know what that is? 1. Somebody said it's 1. Any number raised to the 0 power is going to be 1. Okay? So this, in other words, is gone. We can put x to the 0 here so we can still look at that. Then we got y to the first and y to the third. Well, we got y to the first, y to the third. The shortcut is to subtract. If you don't remember how to do this, just write it out. We got 1y on the top, y times y on the bottom. So this cancels out. 1 times 1, y times y is 1. So here what we have is 1 over y to what on the bottom? To the second power. So this is y to the second on the bottom. Okay. So now we got the z's. We got z to the fifth, z to the second. Subtract. Or you can do the long way like we did this one. But the easiest way is to subtract. What's 5 minus 2? 3. So it's z to the third here. So to simplify completely, I don't even need this x to the 0 power because that's 1. So that's going to be 2, z to the third, 3, x to the y to the second power. Any questions about how we did that? Okay, I'll pause for the pause, give you a chance to write. All right, let's make sure that you understood the first part of your homework assignment. Were there any questions about any of these problems before we move to the workbook? Yes, babe. All right, so with number 5, this is right in standard form. This is the same thing we did in the warm-up. We have 6.7 times 10 to the first power. When you multiply 10 to the first power, that means you're going to move the decimal. This is a positive, so the number is going to get larger. So how many times are you going to move it? 1 time to the right, because that's the only way to make this number larger. So we got 1 time to the right, and that gives me what? 67. 8, you said 8. 1.2 times 10 to the first power, and then 2.3 times 10 to the fifth. All right, so let's multiply these two numbers together, and then let's multiply these two. Or you could have used your calculator for this, okay? So we have 1 times 2 times, 1 times 2. 1.2 times, line up by the number. We got 3 times 2 is what? 6. Then 3 times 1. Okay. Then 2 times 2. 4. And 2 times 1. It's 1 decimal space here, 1 decimal space here. So, and our answer should have a total of 2 decimal spaces. All right, so let's add. This gives us 6, 7, 2. And it should be, do you see that so far? Okay, so now we're going to multiply this together. So that's 10 to the first times 10 to the fifth. So the bases are the same, add the exponents. So this is 10 to the what? It's 10 to the 6th power. So this is going to be times 10 to the 6th. Okay.
Did I get it right? Yep.
And I'll pause for the calls. Any other questions? Yes, baby.
Number 7. I'm not sure what sets are.
Okay, sets. You wasn't here when we did that, but that's real numbers, rational, irrational, a whole number, integer, natural numbers. So let's go through. What set does this belong to. All numbers are real numbers. So for number 7, you're gonna write that it's a real number. It's rational because it can be written as a fraction. It's an integer, and it's also a whole number. Oh, and a natural number too.
What's a natural number again?
Counting numbers. Oh. Natural numbers are counting numbers. Yes, baby.
I have a question about number, I think 6, the scientific notation.
For 34?
Yeah, I don't remember.
It's the opposite of 5.
Yeah, so, oops, I don't know why I put a circle around that. Just ignore me. 34, the decimal's right here, if you don't see it. So in order to write a number in scientific notation, you move the decimal behind the first significant digit. Significant digits are 1 through 9. So I'm going to move, when I read this number, the first number I read is 3. So the decimal goes behind 3. How many times did I move the decimal? Once. So my answer is going to be 3.4 times 10. How many times I moved the decimal? 1 time. Yes. You have to wait for her to come back. Okay. Any questions about that? Let's look at workbook page 26. Workbook page 26. Yes, ma'am.
Notebook today?
I don't know yet. All right, let's look at this one right here. You can write in this. All right, what did you do first? What did you do first, Peyton?
Distributive property.
You did distributive property. Good job. So that's -3 times both numbers in the parentheses. And I don't like the way that feels. So. It's like it just doesn't feel right. It's too bulky. Okay, that feels better. All right, so here, Peyton said we're going to use distributive property. Very good. So when we use distributive property, what did you get there? Yes.
I got -6x
minus 6. Bring down the what inequality is this? Less than. Very good. All right, what do we do after that? What's the very next thing? Yes. You add 6 to both sides. All right. Okay, so when you add 6 to both sides, this is going to give me a -6x. This is less than, and this is going to give me 16. Oops. All right, so now what are we going to do? What do we do now? Yes.
You divide the -6.
Very good. You're going to divide both sides by -6. And what did you get when you divide by -6? So you got x here, and you got negative, what'd you get? -8 over 3. Okay. Now, what happens to the inequality? It's going to flip. Okay. It's going to flip. All right, let's write this. We're going to do that because this is going to be hard to graph this fraction. So let's convert -8 over 3 to a decimal. How many times will 3 go into 8? When we do convert, we divide. How many times will 3 go into 8? 2 times. This gives us 6. Okay. and this is 2. Want a decimal, so I add a decimal 0. How many times will 3 go into 20? 6. What's 6 times 3? 18. When you subtract, what do you get here? 2. What's going to keep happening?
It's gonna keep giving.
So what number is going to repeat?
Six.
Okay. All right. So let's graph this then. When we graph, we're going to put here in the middle, we're going to put 2.6 repeating. We have some numbers on this end. We have numbers on this end. Put your circle here. Are we going to shade in the circle or are we going to leave it open? We're going to leave it open. Are we going to shade to the left? Or are we going to shade to the right?
Right.
We're going to shade to the right because all the values are greater than this. So we're going to shade to the right. And I didn't put the negative sign. Don't forget the negative. Okay. Any questions about how we graph that? All right. Okay, let's look at the next one. Let's look at the next one. V. We have 2 parentheses 4 minus 2x. Close the parentheses. What inequality is this? Greater than. We got 1. Okay. All right. What are we going to do first here? What do we do first? Yes.
First, distribute.
We're going to do distributive property. Okay. When you distribute, yes. When you distribute, Samuel, what do you get when you distribute here? What did you get?
8.
Very good. Minus 4x. Good job. Bring down the greater than sign. Bring down the 1. Okay. Yes, babe. Okay. Okay. What? Yes. Oh, I thought you had your hand raised. Yes, babe. Very good, sweetheart. You're going to subtract 8 from both sides. Excellent job. This is gone now, and I'm left with negative 4x. Bring down the greater than sign. What do I get on this side?
-7.
Negative 7. Now what am I going to do?
Divide -4 by both sides.
Divide by negative 4 on both sides. And this is going to give me x here. What happens to my inequality?
It flips.
It's going to flip. Okay, so now this is going to be, what inequality is this now? Less than. What's a negative divided by a negative? A positive. So 7 over 4, when we divide, how many times will 4 go into 7?
1.
It's 1 time. That gives me 4. This gives me what here?
3.
3. Add a decimal 0. How many times will 4 go into 30?
7.
7 times. Ooh, 7. What's 7 times 4?
28.
28. How many remaining?
2.
2. Bring it down. How many times will 4 go into 20? 5. With how many remaining? And what do I do lastly? Bring up the decimal. Okay. So this is going to give me x less than 1 point what? Okay, so let's graph this. What's the process for graphing this? What do? I have to draw my number line. In the center of my number line, I'm going to put this numerical value, 1.75, and a circle on the number line. A couple numbers on this, a couple numbers over here. Am I going to shade to the left or am I going to shade to the right? I'm going to, this is less than, so I'm going to shade to the left. These values are smaller. Is my circle going to be an open circle or a closed circle? Open, because it's not a part of the solution. Any questions about that? Raise your hand if you got both of those correct. Anybody get both of them right? Okay, just a few people. All right. Yes, babe. Anybody still copying? Make sure you make the correction. You still copy? Okay. Go ahead. What's your question?
How What's the like graphing and stuff? How do you know if you have to shade it in?
The circle, because equal to sign is when you have to shade in the circle. If there's no equal to, then don't shade in the circle. Does that make sense?
Yeah.
That's a good question. All right, let's do number 2. It says solve again and then graph. So this is number 2. We got 2x minus 5. Then we still have, which inequality is this? Less than. Then it's 5x minus 22. Okay. Yes. All right. What are we going to do first? What are we going to do first? Somebody different. He's responded to a lot of them. What do you think, babe?
Add 5.
Okay. Not add 5. If we want to, if it's okay to move 5, but in order to move 5, you're not going to add it. You need to subtract it. Okay. So we're going to subtract 5x on both sides. Okay. It's okay to move the 5x. We'll move the variables to the same side. So when you move 5x, what's 2x minus 5x? Negative 3x. Bring down the minus 5. Bring down the less than sign. This is now gone, and we have negative 22. Okay. Now what are we going to do to get x by itself? Yes.
You can add 5 to both sides.
Add 5 to both sides. Maybe that's what he was meaning. I don't know. All right, so this is gone, and we're left with negative 3x. Bring down the less than sign. Okay. What's negative 22 plus 5? Negative 17. Okay, good job. So now what do we want to do in order to get x completely by itself? Yes. What are we going to divide by? By both sides by negative 3. Very good. So when we divide both sides by negative 3, what do we get on this side of the inequality? We get x. Okay, what about the inequality? It flips because you're dividing by a negative. So now it's going to be greater than. A negative divided by a negative is now what?
Positive.
So let's divide to figure out the decimal. How many times will 3 go into 17? 5. So this gives me 15. When I subtract, I get what? 2. I add a decimal and a 0. How many times will 3 go into 20?
6 times.
6 times. What's 6 times 3?
18.
18. Okay. When I subtract, what does that give me? 2. It's going to keep repeating. Okay. It is going to keep repeating. All right. So we got 5.6 repeated. All right. What's the process to graphing? How do we graph this? How do we graph it? Yes, in the back. Yes. How do you graph it though? We're going to have to move your seat a little closer. So you put this numerical answer here, okay? This 5.6 repeated. Okay, put a circle here. Is it going to be an open circle or a closed circle?
Open.
It's open. Why is it an open circle, do you think, instead of a closed one? It's yes. I gave you a seat closer, but you didn't move there. I don't know why you just stayed there.
No, you would be up one.
No, I'm talking to your little buddy there.
Oh, sorry.
Yeah. So here, look at this one. It's a closed circle. It's an open circle because there's no equal sign. Okay. So when there's no equal sign, it's an open circle. It's a closed circle when it's equal to. Okay. So now this is greater than. So the values that are greater than, and it already looks shaded because I made that too dark. Jesus. I didn't mean to do that really. and this is the side. We're going to do greater than, so we're shading this way. It's an open circle because this is not equal to, so leave it open. And this would be our answer here. This, I kind of messed it up because I made my line too dark. Any questions about that? All right, I need you to take out scrap paper, please, because I'm going to give you some problems to work on. Okay. I gave you a worksheet that looks like this. We're not going to do all of the problems on the worksheet, so please pay attention to the ones that we are going to do. I'll pause this real quickly. So I want us to do the odd. We're going to do all of the odd problems, but I'm going to stop you in 5 minutes to see if you've gotten, how many you've gotten right in that short period of time, because I don't want us to keep going and practicing it wrong. So we're going to do all of the odd, work at your own pace, and I'm going to go and check to see which ones you are doing. Please do this on a separate piece of paper, but you can graph it. Well, you can graph it on here if you want. If you want to graph it on here, you can. The number line is already made, so you can graph it there if you like. Okay. This is what we're working on. Okay, good people. So let's look at the first one. This is 0. This symbol right here is greater than 3x minus 3 minus 6. I'm going to finish this one real quickly. We'll combine the like terms first. So this is going to give us a negative 9. Here, we've got to get rid of both the 3 and the negative 9. We get rid of the negative 9 first by adding 9 to both sides. This gives me 9. Bring down the inequality. This is 3x. I'm going to divide both sides by 3. And 9 divided by 3 gives me 3. The other way to write this, x is here, 3 is here. The mouth is open to the 3. That means x is less than. This is less. So when you shade, you're going to shade the values that are less. This is less. Okay.
Number 1 was 3? Number 1 was 6?
No, don't flip the sign because you didn't divide by a negative. You only flip the sign when you divide and multiply both sides. I knew it. All right, row 1, let's go. We got it.
I got it right. I knew it. I should have kept mine. I got it right. 5. Hey, Joe. And then I got it wrong.
Please make sure you finish your class work. Everybody else, let's go. Please.
So I was
Your class work. Odd problem.
actually I couldn't do this because I can hold the phone.
I've got 45 minutes, and then after that, it's like 6:30. Oh, Hannah, that's so bad.
I'm sorry.
Yeah. Give me this.
Come on, guys, let's go.
What do you want this?
Just put it on my hand.
Thank you, baby. How you doing?
You're very gnarly tonight.
That's what I want.
I'm not the mom. You're the mom. Oh yeah. Wait, no. No.
David say here today. That's a miracle. David say here today. That's a miracle. This to be so bad.
In my room, I'll be my car.
All right, let's work on our warm up, please. Let's work on our warm up, please. Let's work on our warm up, please.